In this video, we are going to learn how to find the area of side-side-side triangles. In order to find the area of side-side-side triangles, we're going to make use of Heron's formula, which is k is equal to the square root of s minus times s minus a times s minus b times s minus c, where s is equal to 1/2 times the sum of all the sides of the triangle. Now you'll see where this comes in to place whenever I show you how to derive the formula first. So we're going to start with the area formula from the last video, which is side angle side. And what we're going to do in order to find the area of a triangle with only sides is I'm actually going to use a double angle formula on this side. So meaning, if I look at sine of c as sine of 2 times c over 2, then the double angle formula states that sine of c should be equal to 2 sine of c over 2 times cosine of c over 2. So I need to figure out what sine of c over 2 is and cosine of c over 2 is, so I can actually replace the sine c here, so I only have sides to deal with. So where I would find these are actually from the power formulas, cosine squared and sine squared, which are 1 plus or minus cosine of c over 2, as I've labeled here. And their formulas just talk about cosine of c, which comes from the law of cosines formula. So that's where it all starts, and that's our end goal, is to get to the point where we're going to replace sine of c over 2 and cosine of c over 2 with just sides. A, B, and then times whatever I can replace here. The 2 and the 1/2 will cancel. So I'm going to start off here. I need to replace cosine of c, so I'm going to solve this equation for cosine of c, which means that cosine of c is equal to a squared plus b squared minus c squared all over 2ab. And if you're wondering why is the c squared negative now, if I was moving a squared and b squared to the left, when I divide by negative 2ab, it changes all the signs up top. So now what I can use this information for is to replace cosine of c. So now I have 1 plus a squared plus b squared minus c squared over 2ab all over 2. And now I want to go about simplifying this fraction. So first I'll multiply the numerator and denominator of the big fraction by 2ab to eliminate the complex fraction. That leaves me with 2ab times 1, which is 2ab, and then plus a squared plus b squared minus c squared all over 2ab times 2, which is 4ab. And now I'm going to rearrange my numerator terms to be a squared plus 2ab plus b squared minus c squared all over 4ab, which on the left here, a squared plus 2ab plus b squared is a perfect square trinomial. So that factors into a plus b squared minus c squared all over 4ab, which again, now I have two perfect squares being subtracted, which is difference of squares. So that numerator can also be rewritten as a plus b plus c, and then a plus b minus c, all over 4ab. Now, this a plus b plus c is right there. I can actually replace it with, if I multiply each side of that equation by 2, I can say 2s is equal to a plus b plus c. So that numerator can be replaced with 2s. It's all over 4ab. But a plus b minus c is not the same. But if I subtract 2 c's from both sides to get negative c on the right, I'll have 2s minus 2c, which can be written as 2 times s minus c. So the 2's can cancel with the 4, leaving me with s times s minus c all over ab. So that's already what cosine's equal to. Cosine squared of c over 2 is equal to. So if I want to find out what cosine of c over 2 is equal to, I just take the square roots. So I'll get the square roots of s times s minus c all over ab just by taking the square roots. Now I'll do the same thing for sine squared. So I'll get 1 minus a squared plus b squared minus c squared all over 2ab. And that's all over 2. Forgot about that too. Which will be equal to, if I multiply the top and the bottom by 2ab, 2ab minus a squared minus b squared plus c squared when I distribute that negative, all over 4ab. And then I'll rearrange my terms slightly. I will move the c squared to the front. Then I'll factor a negative out of this expression to get minus a squared minus 2ab plus b squared to get another perfect square trinomial just like before. And then I can rewrite that as c squared minus a minus b squared over 4ab, which can be rewritten as c plus a minus b. Oop, made a small mistake there. Let me get my white out. And c minus a, but then plus b when that negative distributes, all over 4ab. And very similarly how I got that a plus b minus c, if I subtract 2b from each side, I can get 2s minus 2b, which can be rewritten as 2 times s minus b. And then I can do the same thing over here. By subtracting 2a from each side, I can get 2 times s minus a, all over 4ab, where the 2's and the 4's cancel, leaving me with s minus b times s minus a, all over ab. Taking the square root, I see that sine of c over 2 is equal to the square root of s minus b times s minus a, all over ab. So now I have that part of the formula. So now I can replace sine and cosine. And again, s is just comprised of the sides in my formula here. So I get the 1 half and the 2 already canceled, but sine of c over 2 is the square root of s minus b times s minus a all over ab times the square root of cosine of c over 2, which is s times s minus c over ab. And then I can rewrite this as ab times the square root of s minus b times s minus a all over the square root of ab times the square root of s times s minus c all over the square root of ab. And the square root of ab times the square root of ab is just ab, which will cancel with the ab that's already there. And then I can combine that radical. It gives me that k is equal to the square root of s times s minus a times s minus b times s minus c. So that is where the formula comes from. And it was quite a handful to get there. But now that we have it, you're going to see how easy it is to use. So we're given 3 sides of a triangle. So we'll label it ABC. Side A is 4, side B is 5, side C is 7. And I can now find the area of the inside by starting with S, which is equal to 1 half of all the sides added together. So 4 plus 5 plus 7. which would be S is equal to 1/2 of 12 plus 4, which is 16. So S is equal to 8. And now if I want to use my formula, the area should equal the square root of 8 times 8 minus 4 times 8 minus 5 times 8 minus 7, which is the square root of 8 times 4 times 3 times 1. So K is equal to 8 times 12, which is 96. And then this radical can be simplified by thinking of it as 16 times 6. So 4 square roots of 6 for the area. But how easy was that once you just knew where that formula came from? It's pretty interesting. Let's try it again. So we have A here is equal to 4, B is equal to 3, and C is equal to 6. Finding its area. I'll get S is equal to 1/2 of 4 plus 3 plus 6. Oh, I'm realizing here I need to round my answer to 2 decimal places, so I'm going to come back to this answer in just a minute because I'm going to need a decimal for it. So S would equal to 1/2 of 7 plus 6, which is 13. So that can also be written just as 6.5. And use my formula to show a faster way to write it all out. I have the square root of 6.5 times 6.5 minus 4, which is 2.5. 6.5 minus 3, which is 3.5. And then 6.5 minus 6, which is 0.5. And then I could just plug all of that into my calculator to find the answer. So it would be the square root of 6.5 times 2.5 times 3.5 times 0.5, which gives me the area to be 5.33. And over here, 4 square roots of 6 is 9.8 for its area. Now, how do you use this in practice? Now, let's say you only know the different distances between points. You want to find the area of what's between them. That kind of reminds me of the Bermuda Triangle, which is defined by the distances from Fort Lauderdale to Hamilton, Hamilton to San Juan, and San Juan to Fort Lauderdale. That little triangle between those 3 places, Hamilton, by the way, is in Bermuda, makes up roughly the Bermuda Triangle. So if I want to find how big it is, if I know the distance between these 3 places, which the distances from Hamilton to Fort Lauderdale would be 1,028. So 1,028. And that's what this respectively thing is for. I'm just going to match the order. Fort Lauderdale to San Juan is 1,046. And then San Juan to Hamilton is 965. So now that you know how far all apart these are, you can find the area between them. And it starts by finding first what S is equal to. 1/2 of 1,028 plus 1,046 plus 965. You add them all together. So 1/2 of 1,028 plus 1,046 plus 965, giving me S to be 1,519.5. And the area formula, K, will be equal to the square root of 1,519.5, which is S, times that 1,119.5 minus A, which I'll just say is 1,028. So 491.5 and then S minus B, which would be that 1,519.5 minus 1,046, which is 473.5, times 1,519.5 minus 965. So 554.5. When I take the square root of all of that, I'll get square root of 1,519.5 times, 491.5 times 473.5 times 554.5. I get 442,815.57. And these are miles apart, so this would be miles squared. So about how big the Bermuda Triangle is. Pretty big area on Earth. And that is how you find the area of side-side-side triangles using Heron's formula.